Hello Year 10s and welcome back to Mathematics. We're continuing on our topic of linear relationships. I hope you guys have been well and thank you for the many people who have responded to yesterday's lesson, the last lesson on Tuesday with their responses. I'm still trying to get back to a few people, so please be patient with that. What we're doing in today's lesson is we're actually looking at the midpoint and length of line segments. So by the end of today, we want to be able to calculate the midpoint of 2 points and also find the length of a line segment. So just a quick recap of what we looked at in the last lesson. So last lesson, we looked at plotting points on a Cartesian plane. And so if you remember, when we plot points, when we look at coordinates, it involves two numbers. The first number is our x coordinate and the second number is our y coordinate. And so that is how we plot points on a Cartesian plane. The other thing that we did was we drew linear relationships on a Cartesian plane. And the way that we did this is we drew up a table of values with x and y values. We filled in our table of values with our x values that we wanted to fill in. So for example, 2, 3, 4, 5. And then we substituted these x values into our rule. And we got different numbers. So for example, I could get 7, 9, 11, 13. And then once we've done that, we can actually plot each one of these as one coordinate. So this first one was 2, 7, 3, 9, 4, 11, and 5, 13. The other thing that we did was we applied linear relationships to a few different scenarios where things were increasing at a constant rate. And so we went through an example like the plumber example where there was a call-out fee and then the cost that the plumber charged every hour was the same. So constant increase over time. And we were able to read off these charts by either reading off, depending on what the question gave us. So we could either read off here and then we looked at our y-axis, or we went the other way and then we read down to our x-axis. So that's what we looked at last lesson. What we're going to be looking at this lesson involves things called line segments. Now, if you have a look here, just quickly going through what a line segment is. Now, a line segment, so if you remember for these examples here, so we plotted linear relationships on the Cartesian plane, and what we did was we plotted a few points and then we drew a line through them. Now, these lines can keep going on forever and ever and ever because the rule keeps going on and on and on forever. Even though our table stopped at a particular value, we can actually keep going with this table, and we can keep going on and on and on and on and on and on and on forever. So this is why these lines go on forever. But a line segment is when you draw a line and has a definite starting point and a definite finishing point. So start and end, so there's 2 points that it goes in between. So here, for example, I've got these 2 points, A and B. I don't know what the coordinates are, but a line segment would just be when I have a line that goes between the two of them. It starts at A and ends at B, or the other way around. It has a definite start and a definite finish. So that's what a line segment is. Unlike those linear relationships that we drew in the last lesson where they go on and on and on forever, these ones have a definite starting point and an ending point. So what we want to do is we're going to have a look at a few properties of these line segments. We're going to look at two properties. We're going to talk about a midpoint, and we're going to talk about the length of these, calculating the length of these line segments. So let's talk about a midpoint. Now, I've got here a definition of the midpoint. Now, a midpoint, I forgot to write y and x. A midpoint is the coordinate or point which is halfway between the two endpoints. And hopefully that would, when you look at the word midpoint, you're kind of thinking, oh, duh, it's in the middle or the middle point. The midpoint is just a coordinate or the point which is halfway between the two endpoints. So this is the same drawing that I had before. So when I'm talking about the midpoint, I'm just trying to find the point which is in the middle. So here, let me just fix this up so it lines up a little bit better for me. Ooh. Nope, it doesn't line up. Just fix. Yeah, it's not working nicely. This isn't great. That's okay. Let me go down a little bit further then. So here, there we go. We're trying to find the point which is directly in the middle of this line segment. So here, the point is somewhere around here. And so what we want to do is ensure that each side, so this length over here, is going to be the same as this length over here. And so here in geometry, you might have seen that we've done double dash lines. So we want to find the point so that either side has equal length. So those two, from A to the midpoint and B to the midpoint has the same length. And the way that we do this is something that we've done in data actually recently, where we average the coordinates. So that's what we're going to be doing. So here, these are the steps that we're going to follow if we want to find the midpoint of of a line segment. So the steps that we're going to follow is, first step, we're going to identify the x coordinates for the 2 points. So what we want to do first is we're going to look at the x coordinates. It's just, I arbitrarily picked x because it's nice to do it with x and then we go y, but you could do y as well. Then what we want to do is we want to average the two x coordinates that we find. Once we've looked at the x coordinates, we then average them. So we add the two numbers and then we divide by 2. After we've done that, we repeat these steps for the y coordinates. And by doing so, we will find the midpoint. Now, just a reminder, when we write coordinates, just remember the first number is our x coordinate and our second number is our y coordinate. And so just make sure that you're looking at the same thing for both the coordinates. Okay, so let's have a go at a few examples of this. The first one, we're going to have a look at an example where we have a diagram with us. So what we have here is we've got this diagram and we've got 2 points A and B and they give us the coordinates and we want to find the midpoint of these two. So let me just read the question. Find the midpoint of the interval between A at 1, 2 and B at 5, 8. Okay, so the steps I got you right was we're going to find the average of the two x coordinates and then we're going to find the average of the two y coordinates. So let's first start off with our x coordinates. So here, let me just check my notes here. Excellent. Okay, cool. So first of all, I want to find my two x coordinates. So my x coordinate for A, as you remember, my coordinates, I always write them as x and then y. If you have a look at A, the x coordinate of A is just going to be this 1 here. So my x coordinate of A is 1. So I'm going to look here, x coordinate. My x coordinate for A is 1. And for B, my x coordinate is 5. So what I'm going to do is I'm going to go, okay, I'm going to average these two. So what I'm going to do is I'm going to add the two together. And because there's two numbers, I'm going to divide it by 2. So I'm going to go 1 plus 5 divided by 2. 1 plus 5 divided by 2. And so here I'm going to get 6 divided by 2, which just becomes 3. And so that tells me that the midpoint of these 2 points here, of this interval, is at 3. The midpoint is going to be at x is equal to 3. So if I can already draw this up to the line, and so I know that the midpoint is going to be here. Okay, so we've done this for our x coordinates. We need to also do this for our y coordinates. So the y coordinate for A is 2. I'm going to do 2, and the y coordinate for B is going to be 8. So I'm going to do the same steps. I'm going to add them and divide by 2. I'm going to just take the average. So 8 plus 2, 2 plus 8 divided by 2, and so that gives me 10 over 2, which is 5. And so now that I've done that, all I'm going to do is I'm going to write, therefore, the midpoint. Sometimes we abbreviate this with M, just to show that it's my midpoint. My midpoint is at the coordinate 3 for my x coordinate, comma, 5 for my y coordinate. And so that is how I find my midpoint. So here, if you have a look, it kind of matches up to 5. And so there we go. That is our midpoint for this first diagram, for this first question. Okay, let's have a go at another question. Now, the second question, we're going to have a go at an example where we don't have a diagram given to us. Even though we don't have a diagram given to us, we can actually do the same steps. So let's have a go at this. So find the midpoint of the line segment joining P at -3, or P at -3, 1, and Q at 5, -4. Okay. Now, like I said in those steps, what we're going to do is we're going to find the two x coordinates first. So let's deal with x first. What is the x coordinate of P? Well, if you notice the pattern, just remember our coordinates are always written x and then x and then y. And so for my my point P, it has an x coordinate of -3. So I'm going to write here -3. Then I'm going to also do the same for Q. Now Q has an x coordinate of 5. That's the first number in my coordinates. So I'm going to then have 5. Once I figured out both of these x coordinates, what I'm going to do is I'm going to average them. I'm going to add them together and then divide it by 2. So I'm going to go -3 plus 5 divided by 2. Now -3 divided by 5, -3 plus 5, -3 plus 5 just gives me 2. Now if you're not sure how to do add or subtract with negative numbers, you can chuck in your calculator just to be sure. But just remember, negative, if I have a number line, 0 is here, -3 is here. And when I add, I go to the right. So I go 1, 2, 3 to get to 0. And another 2 to get me to 2. So here, this just becomes 2 divided by 2. 2 divided by 2 just gives me 1. So that tells me that my midpoint has an x coordinate of 1. Okay? Now that we've done that for my x coordinates, I also need to just repeat the same steps for my y coordinate. So let's do that. The y coordinate for P is 1. And my y coordinate for Q is -4. So I'm going to do 1 plus -4. Over 2 because I'm averaging them. 1 minus 4, just 1 plus -4 just gives me -3, and I'm dividing that by 2. You can write this as -1.5 if you like. I'm just going to leave it in this fraction form. It's quite easy to do so. And so my midpoint, therefore, is just going to be following this pattern of my coordinates x first. So 1, comma, -3 over 2. And so that's how we can find a midpoint even if we aren't given a diagram. So we just apply the same steps. Identify your x coordinate first and then average them and then do the exact same steps for your y coordinates. So when we're finding a midpoint, we're trying to average our coordinates. Average our x coordinates and then average our y coordinates. Okay, so that's our first property that we want to find, the midpoint, the point which is halfway between our two end points. The second thing that we need to do is we need to also find the length. Now, the length of a line segment, what I want to do here is I want to find how long it is between A and B. So I want to find how long this, let me try to draw this again. What I want to try and do is I want to try and find how long this line is. I want to find the length between A and B. I want to find how long this guy is. Now, the way we do this is we're going to actually pull out something that we actually learned last year during this lockdown period as well, when we looked at right angle triangles. So what I'm going to do is I'm going to actually draw up, I'm going to just get rid of that blue, actually I'll keep the blue line. I'm going to create a right angle triangle. I'm actually just going to draw here, I'm going to add on 2 extra lines onto my diagram here. So I'm going to add on a horizontal line from A that goes all the way to where the bottom of B would be, and I would line that up with a vertical line that goes from B all the way down to here. And so this creates a right angle triangle. Now I'm just going to copy this diagram over. Just going to copy this, and then I'm going to paste it underneath. Now the reason why I'm going to do this because when I see a right angle triangle like this one here, there's a special rule that someone very long time ago, a guy called Pythagoras, actually figured out that tells you the relationship between the 3 sides of a right angle triangle. So Pythagoras, a Greek mathematician many years ago, identified that if you have a right angle triangle, then the 3 sides are related by this following pattern. So I'm going to call this the side C, I'm going to call this side A, I'm going to call this side B. And so Pythagoras' theorem tells us that C squared is going to be equal to, I'm going to get rid of my points as well, so it's just a diagram, A squared plus B squared. So if I want to find how long C squared is, I just need to go, C squared is equal to A squared plus B squared. So I square the 2 sides, A and B. So just timesing it by itself, or if you have a calculator, some calculators have this funky button which allows you to square that number. So we square the numbers and then we add them together, and that gives me the square of my long side. But we don't want to find c squared. We want to just find how long c is. So what I need to do, if I want to undo a square, I just take the square root. So here, c would just be equal to the square root of a squared plus b squared. And so with the reason why I've actually drawn these lines is because finding these horizontal distances and this vertical distance is quite easy. All we need to do is, if I know the coordinates for big A and big B, if I know the x and y coordinates, I can just find how long A is by comparing the x coordinates and how long B is by comparing the y coordinates. And by doing this, I can actually apply Pythagoras' theorem. So here's the steps that we're going to follow if we want to find the length of a line segment. So here we go. What I want to do when I'm trying to do these steps is, firstly, I'm going to identify the x coordinates for the 2 points. I'm going to find the x coordinates for my 2 points, big A and big B. Then once I've done that, I'm going to find the length between the two x coordinates. So the way I do this is I subtract those two numbers together. If I subtract, that tells me the difference between those two, and so it helps me find the horizontal length. So I'm going to subtract. Usually for this, you want to subtract the bigger number by the smaller number so you don't get a negative number there. Okay, so once we've done that, we've figured out the horizontal distance. What we want to do then is now find the vertical distance. And in order for us to do this, is we want to just repeat steps 1 and 2 with the y coordinates. We just do the exact same thing. We take our y coordinate for B, y coordinate for A, and we subtract the two. And then we find the length between those two. Once we've done that, all we need to do is just put these into Pythagoras' theorem. So use Pythagoras' theorem to find the length of the line segment. So let's have a go at a couple examples of do this. So first one, find the length of the line segment between 0, 1 and 5, 4. Now here they've actually given us a diagram, and it makes it quite easy to do this. So firstly, we want to find the length between the x coordinates. Now I'm going to write this with a funky bit of notation, and little triangle x. Now little triangle x, this is not a triangle, this is actually a Greek letter. This is called delta. Now delta tells me the change, and so that is the same as just writing the length between the two x values. So what I want to do first is I want to find how far away the two x values are for A and B. Now here, because I have this diagram, it's actually quite easy for me to see. I can just count along here. I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units. So that's actually quite easy for, oh, hang on, not 10 units. I realize there's 10 blocks, but it's actually 1, 2, 3, 4, 5. Maybe I should read and look at the diagram more carefully. My bad. So that's 5 units based on the diagram. Now, if you aren't sure, what we can do is we can actually take the two x coordinates and subtract them together. So if you have a look, what's the x coordinate for A? Well, the x coordinate for A is 0, and the x coordinate for B is 5. And so what we can do is we can subtract the two together. So I can go 5 minus 0. Usually take your bigger one and you subtract your smaller one. So here, the horizontal distance, or delta x, is just 5. Okay, now that I've done that, I'm going to do the same thing for y. Now, if you have a look, we can actually do the same thing for y. We can have a look at the diagram and we can count it. So here it's quite easy. 1, 2, 3. And so from the diagram, we can see that there's 3 units between the y coordinate of A and the y coordinate of B. But if you didn't have a diagram, we can just look at the y coordinates, 4 and 1, and subtract the 2. So 4 minus 1, that gives me 3. So first step, what we want to do is we want to find a length between the two x coordinates, and then find the length between the two y coordinates. And so we can do this by subtraction, or if they have a diagram, you can actually just count up how many units there are altogether. That's your first step. Now the second step is then we need to apply Pythagoras' theorem. If we want to find how long this slanted side is, we just need to use Pythagoras' theorem. So here I'm going to write AB to represent the length is equal to the square root of 5 squared plus 3 squared. That's just using Pythagoras' theorem. So Pythagoras' theorem up above was that c is equal to the square root of a squared plus b squared. So if I want to find how long the slanted side was, or that long side, I'm just going to take the square root of a squared plus b squared. And so here we can put this in our calculator. So this just becomes square root. 5 squared is 25 plus 3 squared, which is 9. And so that gives me the square root of 34. Now, you could put this in a calculator and you could get a value. So if I chuck this in my calculator, square root of 34, that would be roughly 5.8. You can check this in your calculator and you get a value like that. But we can actually leave it in this form. Now, if a question asks you to leave it in exact form, this is what it's talking about. This is exact form. If you put the number into your calculator and you take the square root and it gives you a weird decimal number that goes on, that just means that's your the calculator evaluating that for you. You can, if they tell you to leave it in exact form, we can just write it like this and leave it, and that's totally fine. And that's exactly what they're asking for. So here's how we find the length of a line segment. What we want to do is we want to find how long, what the horizontal distance is between the two. So looking at the x values, x coordinates, and subtracting it. Doing the same thing for the y values to find the vertical distance, and then applying Pythagoras' theorem, c is equal to the square root of a squared plus b squared to help me find the length. What we're going to do is one final example where we don't get given a diagram. We're going to still do the exact same steps, but this time we don't have a diagram involved. So here, let's have a look at this one. Find the length of a line segment when given coordinates. So find the distance between the points P and Q if P is at this coordinate, -2, -3, and Q is at 4, 5. Okay, so let's go through the same steps. What we want to do is we first want to find the horizontal distance. I've called that delta x. Okay, let's look for the x coordinates. The x coordinate for P is -2, and the x coordinate for Q is 4. So what I want to do is I just want to subtract these two x coordinates together. Usually what I said was to do the big one minus the small one. So I'm going to have 4 minus -2. Now notice here I've got a minusing a negative number. That's just the same as plussing it. So here this becomes 4 plus 2. And so here we get 4, 6 for my delta x. Delta x is 2x, 6, or the horizontal length is 6. Okay. The second part is I also want to do the same thing with my y coordinates. So let's find our y coordinates. The y coordinate for P was -3, and the y coordinate for Q is 5. And so what we need to do is the same thing, we subtract. So here I go 5 minus -3. When we have minusing a negative, we just add the positive version. So it's going to be 5 plus 3, which gives me 8. And so final step, all we need to do now is just apply Pythagoras' theorem. So here, we want to find the length between these 2 points P and Q. So I'm going to write PQ is equal to the square root of 6 squared plus 8 squared. So I can chuck this in my calculator and check. So check those numbers. So 6 squared happens to be 36 plus 8 squared, which is 64. And so when I add this gives me square root 100. Now with exact form, so here you might be going, okay, we've written it in a square root form. That's exact form, right? Well, what we need to actually check is whether or not this gives me a whole number. So if I chuck this in my calculator, actually have a look what happens. Square root, oh, let me put this in the correct mode. So I've got square root of 6 squared plus 8 squared. That just gives me 10. The square root of 100 is 10. So if there's a whole number that this becomes, we can write it as that whole number. If it gives us a weird number which involves decimals, we can leave it in exact form unless they ask otherwise. And so that's how we find the length of a line segment. So what we covered in this lesson? The first thing that we looked at was we looked at finding the midpoint of a line segment. So what we needed to do was have a look at the two x coordinates and then average them and do the same thing for the y. So when we're trying to find the midpoint, we are averaging the x coordinates and the y coordinates separately. Then when we want to have a look for the length of a line segment, what we need to do is use Pythagoras' theorem. So what we want to do is we want to find the x coordinates and find the horizontal length. And then we find the y coordinates and then find the vertical length. And then once we've done that, we put this into Pythagoras' theorem. And that helps you find the length of a line segment. So that's what we covered in this lesson. Hopefully, if you need to go back on this video and just watch any particular part and go through it again, you can do that. If you have any further questions, feel free to send me an email or ask me a question on Google Classroom. There should be a few questions that have been posted up for you to have a go at. Please have a go at that and practice it to get some more practice. And I will see you guys next lesson, Year 10. Take care and stay safe. Bye.